Alright, so we get to start chapter 13 today. So we're going in chapter 13 to be talking about vector fields and something called line integrals and surface integrals of vector fields. And the goal for today is simply to define with such an object, what is a vector field, to talk about how we sketch vector fields and represent them visually, and discuss briefly what are some vector fields that might arise in physical applications, some examples of those. Alright, so what is a vector field? And we'll start right now on vector fields in 2 dimensions rather than in 3. A vector field is just a function whose input is a pair xy and whose output is a 2-dimensional vector. So a vector field takes in 2 numbers and produces 2 numbers, essentially. Takes in a point and then associates a vector with that point. For example, we might have a vector field which takes in the points x and y and produces the vector whose first coordinate is negative y and whose second coordinate is x, positive x. For example, if I evaluate the vector field at the point 0, 1, the associated vector will point in the direction negative 1 and 0, because y, negative 1, becomes a negative y in the x-coordinate, and an x value in the point of 0 becomes a y-coordinate in the output of 0. Now let's talk about how we visually represent vector fields. We visually represent vector fields on the xy plane. So let me sketch that first of all. Then we take a point in the xy plane, such as the point 0, 1 that we considered in our brief example over here on the right side. At the point 0, 1, the vector field output the vector negative 1, 0. So I'm going to draw the vector negative 1, 0 with its tail at the point 0, 1. At the point 0, 1. So here I am at the point 0, 1 on the y-axis, and starting from that location I'm going to draw the vector negative 1, 0, extending 1 unit in the negative x direction. Okay, let's try another point. Let's consider what happens if we plug in the pair 1, 0 to this vector field. If the first coordinate x is 1, then that becomes a 1 in the back coordinate, and the y of the input is 0, which means our negative y will become negative 0, or simply 0. So at the point 1, 0, I'm going to draw the vector 0, 1. At the point 1, 0, I will draw the vector 0, 1. So from here, it's going to point straight up in the positive y direction. And we continue to do this process. Let's plug in perhaps let's do f of 1/2, 1/2. F of 1/2, 1/2, the second coordinate will become negative and come to the front. First coordinate will swap to the back. And so at the point 1/2, 1/2, we have a vector with a negative x component and a positive y component. And so, 1/2, 1/2 is right here. And so that point will stretch out in this direction. Now, sketching a vector field means drawing in several such vectors. Not so many that the graph becomes hard to understand, but enough that you begin to understand a general pattern. For example, I might do a couple of these, maybe that vector will point to the bottom right. I might do a couple of these, just enough to see this circulating, swirling pattern in the vector field. You don't want to draw too many because it takes a lot of time and it will just clutter the picture. So draw enough vectors to get a sense of the flow. But don't clutter the picture. This would be an example of a sketch of a vector field. Now, common examples of vector fields, of functions which associate a vector to a certain point. One quintessential example is a force field. So a force field is some force which is acting on objects spread across 2 dimensions. A quintessential example would be gravity, for example, in 2D. You have some central object which has some mass, and because of its gravity, it's exerting a force on objects all around it, pulling in objects toward it. And the magnitude of the force gets smaller and smaller as you move away from the object. That gravitational force gets weaker and weaker. So this would be an example of a gravitational force field. Another type of vector field that you see quite often is a velocity field. And that's what I think of probably when I see this swirling vector field up here. I think maybe of something like a whirlpool, where we're observing the movement and the velocity vectors of particles of water in a whirlpool or a maelstrom, or something of that nature. As well, you can represent magnetic fields using vector field. So we'll see applications of the techniques of vector fields in particular to force fields. This will be our focus in terms of applications for this course. But as you go into physics and potentially engineering, especially electrical engineering, you're likely to see these other two show up quite often as well. Now tomorrow we'll get into more detail. Today was just an overview.